Welcome to qnawire.
Okay, so we are being asked to find the intervals on which f is increasing or decreasing, the local max and min, and the intervals of concavity and inflection point of f of x. So in order to find where f is increasing or decreasing, we apply the first derivative test. So we have to first take the derivative of f of x. So f prime of x is equal to 4x cubed minus 4x. And then that could be further simplified by, and we set this equal to 0, but we're first going to simplify this further. So we can actually pull out a 4x, and then that will leave us with x squared minus 1. And we set this equal to 0. And we solve for different cases in 0. So we have 4x equals 0 and x squared minus 1 equals 0. Well, this gives us that x is equal to 0. And since we add the 1 over and then take the square root, the square root of 1 is 1, but remember that when you take a square root, you have a plus and a minus, so you get negative 1 and 1. Or you could also look at this as x plus 1 times x minus 1, and then solve that for 0, and that will give you the same answer. So now that you have these values, I like to make a sign chart, as I've explained before. So I will have this would be the number line right here. This is a horrible line. This is the number line, and I will put values on which I'm interested in, and which are these numbers, and then on my x side, I put the factors of multiplication which I'm interested in. So in this case, it'll be 4x and x squared minus 1. Since these are both parts of the function that are being multiplied to give us f prime. And then we're going to look at negative 1. So that's 0 and 1. Let me bring this over. And so this is basically like a sign chart. And then when you multiply these together, you get the sign of f prime. So any value less than negative 1 for, when you plug in value less than negative 1 for 4x, you get a negative number. And then for any value between negative 1 and 0, you also still get a negative number. And any value greater than 0 and 1, you get a positive number and then a positive number. And then for x squared minus 1, if you plug in values less than negative 1, you get a positive number because you're squaring it. And any values between negative 1 and 0, you get a negative number. And then negative number between 0 and 1, and then a positive number. So now you multiply across, so positive times negative is negative, negative times negative is positive, positive times negative is negative, and positive times positive is positive. So now that this tells us the signs of f prime, we know the intervals on which they are increasing and decreasing, which I will write here. So it is increasing where f prime is positive, so it is positive between negative 1 and 0, so we'll do negative 1, 0, union, and it's also positive from 1 to infinity. And then it is decreasing where it is negative, so it'll be negative infinity to negative 1, and then 0 to 1. And we can also find out our local max and mins. So I'm going to write L max. Remember that this tells us the direction in which the graph is moving. So this is decreasing, increasing, decreasing, and increasing. So where our function is going from negative to positive, we have a local min. So L min. And then the opposite is true for, so if it's going from positive to negative, you have a local max. So then this occurs at 0 and negative 1, and the local min occurs at negative 1 and 1 for the reasons I stated. Now, to figure out the concavity, we have to take the second derivative, and set that equal to 0. So the second derivative of this is 12x squared minus 4. This will be 12x squared minus 4. And we set this equal to 0, but we can also simplify this further. We can pull out a 4. This will give us 3x squared minus 1. And we set this equal to 0. And we solve for 3x squared minus 1. And that will give us x is equal to plus or minus square root of 1 over 3. And now we are going to repeat a sign chart again, but this time for concavity. So this time we'll have negative root 1 over 3, and we have positive root 1 over 3. And then our only term that we're interested in is 3x squared minus 1. And if you plug in values less than negative root 1 over 3, you get numbers that are positive. If you plug numbers between these, negative root 1 over 3 and positive root 1 over 3, so you get numbers that are negative. And then if you plug numbers greater than root 1 over 3, you get positive. So and these tells us the sign of f double prime. And so if f prime is positive, which it is in this case, it is concave up. If it's negative, it's concave down. And if it's positive, it's concave up. So our intervals, so con up is negative infinity to negative root 1 over 3, and union positive root 1 over 3 to infinity. This should be written like this, yeah. And then down, concave down, occurs between negative root 1 over 3 to positive root 1 over 3. And their inflection point occurs when we have changes in the signs of concavity. And this occurs at negative root 1 over 3 and positive root 1 over 3. So inflection point occurs at plus or minus root 1 over 3. And that is all.